messed up myself.
Oh my gosh, I'm so sorry.
When I was putting Friday's class onto YouTube, the first reel is missing. The first file, there we go, that's the word.
That would explain it, it's must have jumped in the middle.
Yeah, because usually the video starts with me walking in front of the camera, but I have no idea what happened. And that was the best part.
Maybe your phone ran out of space and overwrote something.
That would be very bizarre, but possible. All right, Poison?
Yeah, it's on one of the old test problems that, I hinted you about.
Right.
So, it's 5CI on the fall 2018.
I'll need more detail than that.
It says how high would it go, and you told me, the steps to get it, but when I do it, I'm not getting the answer that the answer key is telling me.
So what you're saying is my answer key is wrong? Is that a direct challenge? That would be mine. I would like to think that mistakes for tests going back that far, someone else would have caught, but I'm only surprised that, something be posted for years and suddenly someone points out a mistake and they go through the wonder, why did no one see this before? All right, so this was the Strange Planet.
Yeah, so it's the one where he drops a rock from a height of 2.5 and, yeah.
All right, so if so from that we get the acceleration due to gravity was,
It was negative 3.472.
meters per second squared, all right? And again, this came up in the discussion earlier. Acceleration due to gravity is a catchphrase in physics. It is a scalar. Little g here, you don't put a vector symbol over it. This is the acceleration due to gravity. If you're calculating what the acceleration due to gravity is and you make up positive, you will get a negative acceleration. But acceleration due to gravity is the scalar, because the negative is purely directional. All right, so that was for part A. Part B was dealt with how hard does he jump, how fast does he jump, or how fast does he throw the rock?
Basically how fast was the rock going when it was released? And
It went from 1.5 meters to 30 meters?
It was the one where we subtract.
All right, so the initial velocity was 14 point something?
Yeah, it was 14.07.
237?
No, 14.07.
07.
Yeah.
Sorry, the voices in my head are telling me something different. All right. And then we get to where your actual question is. What was the actual question again? What was the problem first?
So it says the rock is then tossed straight up on a moon at the speed found in the problem above. How high would it go?
You say on a moon or the moon?
On moon.
On moon, okay.
Very specific.
Presumably ours. So the acceleration due to gravity on our moon is.
Well, no. It deals with the strange planet, so I use the
Oh.
I use the 3.472.
Yeah. Strange planet, throws the rock straight up, how fast is it going when it's released?
I use this, and the final velocity.
That is a bizarre question, because it looks like it did a cut and paste and only changed part of it. I believe that is our moon.
Oh,
Yeah, I think that's the intent.
In my, in year, I said, yeah, so I just gotta change this to 9.8.
No, our moon is 1.6 or 1.7.
Okay. I thought, cause it said 5C, so I assumed that it was like the same.
Only in the fact that it's pulling the speed for the Part B.
Okay.
Yeah, that was one that in the middle of the test, someone, I hope, asked at the time. Alright, it sounds like your question has been resolved. Yeah, that was,
But like on the test, you would tell us that the acceleration on D moon was
Yeah.
is the 1.8.
you look at the top of the very first page, and I have
Oh,
values of
yeah.
G there for things that for things like that.
Okay.
All right, yes, Ben.
Are you going to have the same formula sheet for our test?
It should be, we've been using this textbook for a while, so it should be the same formulas. I did a cut and paste for the formulas from the spring, which presumably was a cut and paste from the previous fall, which was a cut and paste from, and so on. Any other questions? All right, so let's pick up where we left off. And under the risk of accidentally deleting a file.